The next speaker is Neil G4LDR. And Neil is experiencing maybe the same things that we have experienced at Goonhilly, namely to activate the big dish. He is part of the group that activated the iconic Goonhilly Earth Station on EME. And we know how it feels to be in a big dish, you know. It certainly wasn't easy, I heard, and it took quite some time to get it really on the air. But I think it was quite an effort to use a 32-meter dish. It's even bigger than Goonhilly. So we are quite interested to hear your stories. Go ahead.
Okay, thank you very much, and good afternoon, everybody. And yes, I'm going to talk to you about the work we did at Goonhilly Earth Station back in 2017. And I was only involved in the very last phase, the EME operation, at the end of August last year. Brian and other people were involved with earlier stages of the expedition, of the trips down to Goonhilly. Let me stand out of the way. If I can just... Golf Bravo 6, Golf Hotel Yankee. Bravo 6, Golf Hotel Yankee, FM. Now, I heard somebody say no echo. Now, I play that when I give this presentation to radio clubs in the UK, and I always say, can you hear the echo? And they, no. And I say, those were the echoes. Okay, I'm going to give you a little bit of history of Goonhilly, and then I'll talk about how we got access to Goonhilly, the actual details of the dish that we used, and the initial reason we were down at Goonhilly was to do some digital amateur television tests, and then eventually we got to do 2 days of conventional EME on the 6 SEMs and the 9 SEMs bands. Also talk a little bit about some performance tests we did on the dish for the owners of the dish, and then I'll talk just briefly about the future of EME operation from Goonhilly and the future of Goonhilly itself. Goonhilly is situated on the Lizard Peninsula in the southwest of England in the county of Cornwall, so it's quite a long way from anywhere. But the reason it was located there was it came into existence in order to provide communication capability through the early low Earth orbiting satellites between the UK and the US, and particularly the Telstar satellites. And the reason why it was so far southwest in England was to give the maximum mutual visibility between the US and UK, which was actually about 20 minutes was the maximum time. The first dish that was built at Goonhilly was named Arthur. It was started construction in 1961, completed in 62, and it was a large dish, 26 meters, in order to be able to receive the what are nowadays low power, we consider low power satellites, and it had to be steerable and be able to track the fast moving low Earth orbiting satellites. It had an uplink of on 6 gigahertz and downlink on 4 gigahertz. And it was used to receive the very first transatlantic TV via the Telstar satellite. Though I'm afraid I have to admit that Goonhilly wasn't the first to receive the test transmissions via Telstar. The French beat us to it. Allegedly, the reason, allegedly, the engineers at Goonhilly had set up the feed to the wrong polarization for the very first test. And I remember seeing on the TV, and it's also on YouTube, all that they got at Goonhilly was some very rolling pictures and some very fuzzy pictures of a man in the States, but they never got the pictures to lock up on that very first test transmission. So there we are. So the French beat us to that. Right. Goonhilly, obviously, geostationary satellites soon replaced low Earth orbiting satellites for international communications, so there's no requirement to actually track a moving, fast-moving satellite, so fixed dishes could be used. Satellites had greater power available, better solar panels, more output power, and also receivers became more sensitive both on the ground and on satellite, so you could get away with using smaller dishes. At its peak, Goonhilly became the largest Earth station in the world, with 64 dishes in traffic at one point. But gradually, as we know, most international traffic, communication traffic, moved to fibre optics, undersea fibre optics. Of course, the big advantage there is that you potentially have unlimited bandwidth, which you don't have if it's a radio link to satellites. You just lay more cables if you want more bandwidth. And I guess if it wasn't for that, we wouldn't have the internet today, and the amount of data that's rushing around the world, it couldn't be carried just by satellites. Then in about 2006, British Telecom, the owners of Goonhilly, slowly started to move their satellite operations away to their other site in the UK, which is in a place called Madlenley in the centre of the UK. And by about 2010, Goonhilly was mothballed, and the visitor centre, which I think had about 40,000 visitors in the last year it was open, was suddenly closed in 2010, and the whole operation was mothballed. The site was eventually sold to a company called Goonhilly Earth Stations, GES Limited, in 2014 for, I think, about £1, wasn't it? Something like that, Brian? Yeah. GES Limited are a group of satellite engineers who are basically funded, backed by city investors. They've been building up the site again, repairing about 10 years of neglect, and they've got all the small dishes in traffic now, all but the large 3 dishes that remain there, and they're actually installing additional dishes because they've got customers who want to use them for satellite communication. So how did we get into Goonhilly in the first place? Well, it wasn't the EME community that actually initially gained access. GS Limited were very keen to support the program that ran, well, the British astronaut Tim Peake was on board the International Space Station, where a number of schools could bid to have time talking to Tim Peake on the International Space Station, and the video from those contacts was downlinked on the ham TV system from the ISS on 13 centimetres. And Goonhilly offered the use of the 13.8 metre dish. And it was the British Amateur Television Club and AMSAT UK who initially set that up. Anyway, whilst after this was so successful, Noel, who was one of the people down at Goonhilly for our test last year, asked the people at Goonhilly, could we use one of the bigger dishes to try and see if we could bounce some digital amateur television off the moon, something that had never been done before. There were 3 dishes available. There was Arthur, the very first one. that had been decommissioned, but it actually had been moved in azimuth and elevation fairly recently. Goonhilly 3, built in the 70s, that really needed an awful lot of investment to get it operational. But there was GHY6 Merlin, which was built in 1984 to work the transatlantic Intelsat. That was 32-meter diameter. It was fully operational, but it had been decommissioned. So the answer was that they offered us GHY6 to play with, or offered the television people. GHY6, it weighs 410 tons. It actually sits on top of the control building, and it had a receive frequency of it's 32 meters diameter, by the way. It has receive frequency 3.6 to 4.2, transmit on 5.8 to 6.4, receive on X-band, or say Ka band, and also, transmit on Ka band and receive on X-band. So those are the frequencies it was designed to work. It has what is called, or what is described as a Cassegrain reflector with mirror tunnel feed, or what we might know as a beam waveguide structure. And the actual tube that comes out in the centre of the dish is large enough to drive a small car down it. I must add to American colleagues that it's a small British car. It's about 2.6 meters diameter, the actual tube that looks up at the Cassegrain reflector. And this has the advantage that all the feeds end up in the control room, which meant that it was ideal for connecting any equipment that we wanted to connect for EME operations. Moving GHY around the track, very similar to what we saw yesterday. It has 4 motors, individual motors on each of the 4 wheels to drive it around the track for azimuth. 2 large motors for elevation. That's the track that it drives around with the motors. That's the elevation motors down there, and the big wheel that orders the elevation. And as I mentioned earlier, it doesn't have to track. It was the control system to move it was a positioning system rather than the tracking system. Now that causes a bit of a problem. Because when we came to use it for EME, of course, we couldn't just sort of set the thing off tracking the moon. What had to happen was that the predicted position of the moon had to be calculated ahead of time, and a lookup table was produced, an Excel spreadsheet, and some software was written which would read the Excel spreadsheet at the correct time, would then send the data to the 1980s, I've done what I didn't want to do. The 1980s control system, which actually had been updated to have a USB port on it, so that was the easy bit. But basically, every, I think, 20 seconds, the dish would be repositioned as opposed to tracking the moon. It's a 14-bit system, and 14-bit encoders on the for azimuth and elevation, able to read out the position of the dish to 100th of a degree. So I know John was saying having trouble with positioning to half a degree. So this is pretty good. The being waveguide, unfortunately, we have never been able to have a look at what it actually is, because it's all enclosed at the base of the in the control room underneath the dish, and B, There are no existing diagrams at Goonhilly as to what it is. There are no construction diagrams or schematics. Goonhilly Earth Stations have recently contacted Mitsubishi, who built the dish, to see if they could supply any details, and they came back and saying, we're glad you're still using our equipment, but it is obsolete and we no longer support it. So we didn't get any details back from the manufacturers. So this is how we think it works at the moment, but I know Brian has been having discussions with several people, and this may be completely wrong. We're hoping to find out some more information later. But basically, no, I've done it again. Right. This is the beam waveguide, comes down that mirror. The low band feed goes out first, the higher frequencies pass through, again a second mirror, and finally the high band feed comes out the bottom. And the beam is steered up through the large diameter beam waveguide with a series of mirrors, effectively. And this is the only picture that we've recently got from Goonhilly, which is the section above the control room, and that's the sort of dish up there. This shows just the power cables going up to the motors and the sensor cables coming down. And in the centre is where the RF goes, and it's a segmented tube which is either stepped or gradually changes diameter. And it obviously has something to do with the way that the frequency selection for the various bands, but we just don't know the details yet. Right, throwing a few figures into the VK3UM calculator, and we can see that we've got plenty of gain with this size of dish, 59 dBi on 9.7, 64 on 6, beam widths 0.2 of the degree and 0.1 of the degree on the two bands, and those are the output bands. So basically, we've got plenty of gain, and so we should be a big signal. If we were, we were going to use amplifiers about 50 watts on 9.7s and 40 watts on 6.7s. So and those signals and noise figures for what our partner stations at the other end of the QSO would see are based on a CW bandwidth of about 250 hertz. So would digital ATV work? The TV people set up with the assistance of Brian, who provided some of the kit, and also did the initial narrowband test to prove that you could actually get an amateur signal on the 9 and 6.7 band up to up through the dish and back again. So we had good echoes coming back. They tried with TV at 250 kilo symbols per second, and obviously at that sort of bandwidth, the signals are going to be coming back off the moon are going to be very much weaker, 1,000 times weaker than a CW signal. But the major issue, of course, as we all know, is that you're not going to get effectively a T9 note coming back off the moon. You're going to get a lot of phase distortion because of the uneven surface of the moon. So, did digital ATV work? No, it didn't. And if you could have predicted it wouldn't, but they were very keen to try it. They did try AM TV as a last out, and they did get just here. This is the signal they got back with AM TV, but no sync forces, no digital information, of course. Right. Following that initial test with TV, the British Broadcasting Corporation, BBC, we're filming a program which was hosted by Michael Portillo, who was a British politician in the former life, but now does documentaries on TV, and filming a program on railways, which was going to end in Cornwall. And they were going to come to Goonhilly as the last part of the program. And the question that Goonhilly Earth Station asked was, could Michael Portillo bounce his voice off the moon? And of course the answer was yes. So Brian and Noel went down to Goonhilly, set up the system, and I think you used 6 centimetres as the band that was used. So Brian and the rest of the people were just famous for 2.5 seconds. So that's Michael Portillo in the bright pink jacket, and that's Brian and him sat actually during the 2.5 seconds that Brian was shown on TV. Brian once, I don't know what sort of fee you got for that, but I guess it wasn't an awful lot if you were paid by the second. Yeah. Right, okay. Down to the real business of 2 days of EME. So last August, we went off down to Goonhilly again and set up 6 centimetres and 9 centimetre band. And as I said, we in the introduction, we were also going to carry out some tests. That was the team of people that went down to Goonhilly. Neither myself or Noel are CW operators, so we weren't much good at operating. But Tim here, Brian and Ralph were the main people who provided the QSOs. And of course the object was to work as many stations as we could in as many continents over the 2-day period. Contact on CW and SSB, we did no digital. You weren't set up to do digital. Equipment, basically standard transverter, as I mentioned earlier, about 50 watts output on 9 SEMs and 40 watts output on 6 SEMs, except on day one, where the amplifier that we used on 9 SEMs had a maximum input voltage of 12.6 volts, and it got set up with 13.8 volts on the supply. And when that happens, it just cuts right down to about a few watts. So we were actually only transmitting a few watts of RF on day one. So we were ready on day one for when the moon rose for work VK. We had a short mutual window, and almost a few minutes after moonrise, we were in communication with VK3NX on 9 SEMs. He then rushed out and changed over to 6 SEMs, so we did 6 SEMs contact with him as well. Next contact was with JA4BLC on 6 SEMs only, no 9 SEMs in Jan. Then we worked some Russian stations, followed by loads of European stations. No contact with Africa because there was nobody on the bands from that continent. But we finally worked South and North America, Brazil, Canada, East and West Coast, US. I've just got I won't play these all. They're on the USB stick that you've got, so you can play them at your leisure. I think I'm going to have to go over and do it over here. Oops, sorry. Let's go back. That's okay.
I haven't mentioned that you have a bit more than 5 minutes.
All right. Okay. So here's our own echoes on. I'll play one more. This is Peter on SSB. those are just some of the operators that we had. Day 2 was more SSB contacts, and also they wanted us to do some tests on the reception of Taurus A. I think it's Brian's idea to do this, so we positioned the dish on Taurus A because we couldn't track it, we waited for it. We knew exactly when it should arrive and we should see the signal. Nothing appeared. So what was wrong? We realised that the chief scientist at Goonhilly had programmed the location using his home QTH a few kilometres east of Goonhilly, and of course, had we been there, we would have heard it on time. It arrived about a minute or a minute and a half late. That's just the sun noise that we measured, about 3 dB down on what we should have seen. That's the Taurus A measurement on 6 centimetres. And I think I've just about got time to play a piece of video.
So the dish is moving round on Taurus at the moment. Neil, you're looking to see the signal peak when the dish is actually pointing at that star, yeah?
Yes, that's right. What we're looking at on the screen at the moment is just the signal from the code sky, and we will see the signal here increase as Taurus comes into view of the antenna.
So how far away is Taurus from us then, Neil?
At the moment, it's approximately 6,500 light years away.
Wow. So in other words, when that signal peaks there, we're going to be looking at a radio signal that left its star 6,500 years ago.
Yes, that's correct.
It's quite hard to get your head around that, isn't it? So why are you doing this at the moment? Why are you tracking that star?
We're tracking the star because the output of the star is a known radio source. So we're trying to, if you like, calibrate or trying to determine the efficiency of the dish and the feed system and all our equipment connected to it to see whether we get anywhere near the level of signal that we expect to get.
That's amazing. And it also helps you to make sure that everything is lined up correctly when you turn that dish on the moon, that we might get some QSOs.
That is correct. And there we are, just about reaching peak now.
Okay, the $20,000 question then, Neil. Are you seeing the level of signal you're expecting to see?
No, we're not quite seeing the signal that we should see at 3.4 gigahertz. It's mainly due to the issues with the dish here is not designed to go quite down to the 3.4 gigahertz amateur band. It's designed for slightly higher frequency. So we're seeing about 3 dB less signal, about half of what we would expect to see with this size of dish.
So factoring that in, then you are seeing the signal level you expected, yeah?
Yes, we are indeed.
Okay, I was going to talk a little bit about why signals were weak. We were receiving weaker signals than people were reporting us, but I'm running a little bit out of time, and I just want to say a little bit about the future of Goonhilly and EME operation. By 2022, there's going to be about a 50% shortfall in capability of the European Space Agency's Deep Space Network to track all the spacecraft, both existing and those that are planned, both government and commercial flights. Goonhilly has now got funding of about 8.4 million, pounds to upgrade the system, and they're going to start refurbishing GHY6 in late 2018. And it's been further announced they've actually got some funding now to support the moon landing programs, the commercial programs that are going to sort of kick off in the next year or two. So they will be using these big dishes for that. So no more opportunities for use of GHY6 for EME, or are there? Well, when I put this slide together originally, there wasn't, but there's been developments, and to cut a long story short, we will be operational from Goonhilly on 6 and hopefully 9 centimetres again on the weekend of the 1st and 2nd of September. Okay, that's the first thing. The second thing, briefly, is that longer term, we would like, and Goonhilly would like a proposal, to actually get the original GHY1 dish back into operation. And we'd love to do it. It wouldn't just be for EME, it would be for educational purposes and for radio astronomy. However, we don't know how much it's going to cost, but we think as a roundabout figure, it might be £5 million in order to do that, or might be more, might be less, but it's an awful lot of money, and how are we going to raise that amount of money? Brian has been talking to 1 or 2 people, and we perhaps need to initially do a survey of what actually needs to be done to make GH1 serviceable again, but that's obviously much longer term. Okay, that's my presentation.
Well, thank you very much. And I can see a lot of similarities. First of all, of course, the level of the echoes. From what you demonstrated, that sounds like it's as strong as Dwingelo. But, okay. And also, quite interesting is that the contract, the rental contract, it also has a similarity, except that our contract costs €1 instead of £1. Yes. So so that's cheaper. Anyway, our contract in Dwingelo ends in 2 years. I hope your contract goes a little bit longer then. But of course, we are confident that our contract will be renewed in 2 years, because that's the intention. And the difference is the weight. I think the weight of your dish is quite a lot more than Dwingelo. It's only 120,000. Only 120,000. Thank you very much. Bye-bye.